Have you ever gazed at the night sky and wondered if we are truly alone in the universe? A question as intriguing as it is complex, it has been a subject of fascination and relentless exploration for centuries. We find ourselves standing on the brink of a new era, one where it's not just about exploring our own celestial backyard, but about venturing out into the vast expanse of the galaxy in search of life beyond our solar system. The stars, those twinkling lights that adorn our night sky, hold secrets that could potentially answer this age-old question. Among them, the red dwarfs, the most common type of star in our galaxy, hold a particular interest. Their abundance, longevity, and unique characteristics make them stellar beacons in our quest for extraterrestrial life. So, to navigate this cosmic question, we embark on a journey to the most common stars in our galaxy, the red dwarfs. Red dwarfs, the humble heroes of our galaxy, make up about 70 to 80% of all stars in the Milky Way. That's right, the majority of the stars twinkling in our night sky are these stellar underdogs. Now you might be wondering, what exactly is a red dwarf? Well, let's dive into that. Red dwarfs, also known as M-dwarfs, are the most common type of star in our galaxy. They're small, not much larger than our own Jupiter, and they're cooler, with surface temperatures that can be just over half that of our sun. Their red hue comes from this lower temperature as cooler objects emit light in the longer, redder wavelengths. But don't be fooled by their diminutive size and cooler nature. These stars are stellar powerhouses. Despite being smaller and cooler than our sun, red dwarfs are incredibly abundant. Picture this. For every sun-like star in our galaxy, there are at least 3 red dwarfs. This means there are billions, yes billions of these little stellar heroes scattered throughout the Milky Way. But why do we compare them with our sun? Well, we do this to provide a perspective. Our sun, a yellow dwarf, is an average-sized star. By comparing red dwarfs to our sun, we can better understand just how small and cool these stars really are. And yet, their sheer number makes them a major player in the cosmic game. In terms of temperature, red dwarfs are significantly cooler than our sun. With temperatures ranging from 2,500 to 4,000 degrees Celsius, they're much cooler than our sun, which blazes at a fiery 5,500 degrees Celsius. Again, this is a testament to their cool, low-key nature. In the grand scheme of the cosmos, red dwarfs are the quiet, unassuming majority. But their sheer number alone makes them significant in our search for life. As we continue exploring the universe, these stellar beacons, with their unique characteristics and abundance, might just lead us to the answers we seek. Time is a key ingredient in the recipe for life, and red dwarfs have it in abundance. When it comes to the lifespan of stars, red dwarfs are the Methuselahs of the Milky Way. Unlike their larger counterparts, which burn through their hydrogen fuel with reckless abandon, red dwarfs are much more frugal. They consume their fuel at a snail's pace, extending their lifespan to an almost unfathomable length. We're talking trillions of years here, people. That's a lot of zeros. In fact, their lifespans are so incredibly long that no red dwarf has ever died in the history of the universe. They simply haven't been around long enough. This extended lifespan provides a stable environment for planets in their habitable zones. Think about it. With such a long-lasting energy source, planets orbiting red dwarfs have a significant amount of time for life to potentially evolve. In contrast, a planet orbiting a larger star would have a much shorter window of opportunity before the star exhausts its fuel and dramatically changes the conditions on the planet. However, it's not all roses. The longevity of red dwarfs also presents a potential challenge. See, during the early stages of their lives, red dwarfs are known for their vigorous flare activity. This could potentially strip a nearby planet of its atmosphere before life has a chance to take hold. But as the red dwarf ages, it calms down, and its flare activity decreases. This means that if a planet can weather the storm of the star's tumultuous youth, it could enjoy a long, stable period of potentially life-friendly conditions. In the grand cosmic scheme of things, red dwarfs are like slow-burning candles offering a steady, lasting light. They provide a persistent, consistent energy source which could potentially support the evolutionary dance of life over incredibly long timescales. This longevity offers a tantalizing opportunity for life as we know it to take root. Every star has a Goldilocks zone, a habitable region where conditions might be just right for life. But life around a red dwarf could be quite different from what we're used to. Picture a cozy ring around a star, a region where it's not too hot, not too cold, but just right for liquid water to exist. This is the habitable zone, often referred to as the Goldilocks zone. For red dwarfs, this zone is much closer to the star than it is for stars like our Sun. This proximity has a peculiar effect. Planets in this zone are likely to be tidally locked. Now, what does tidal locking mean? It's a gravitational interaction where a planet always shows the same face to its star, much like our moon does to Earth. This means one side of the planet is in perpetual daylight, while the other is in eternal night. Such extreme conditions could result in starkly contrasting climates on the same planet, which could be challenging for life as we know it. But wait, there's more. Red dwarfs are notorious for their temper tantrums. They frequently throw out powerful flares, bombarding their nearby planets with high levels of radiation. This flare activity can strip a planet's atmosphere away, leaving it barren and inhospitable. Yet, it's not all doom and gloom. These flares might also be a source of vital energy, sparking chemical reactions that could lead to the formation of complex molecules, including those necessary for life. Life, if it exists around red dwarfs, might have to be resilient, capable of withstanding harsh radiation or extreme temperatures. It's also worth noting that red dwarfs are quite dim, which means that photosynthesis, as we understand it, might not be an option for life on these planets. Instead, life forms might rely on other energy sources, like the heat from volcanic activity or chemical reactions. These challenges, however, could also be catalysts, pushing life to evolve in ways we can scarcely imagine. The hunt for planets beyond our solar system, known as exoplanets, has uncovered a wealth of worlds orbiting red dwarfs. The search for these celestial bodies has been made easier by the unique characteristics of red dwarfs. Due to their smaller size and mass, detecting planets around these stars using the transit method or radial velocity is less challenging compared to larger stars. The transit method involves observing a star's light dimming as a planet passes in front of it. With red dwarfs being dimmer than most stars, this dimming effect is more noticeable. This method has been instrumental in detecting exoplanets around red dwarfs, opening up a new frontier in our quest to find other worlds. Radial velocity, on the other hand, measures the tiny wobble of a star caused by the gravitational pull of an orbiting planet. Since red dwarfs are less massive, even a small planet can cause a noticeable wobble, making it easier to detect. But it's not just about the ease of detection. The planets we've discovered around red dwarfs are proving to be fascinating in their own right. Take, for example, the planets around TRAPPIST-1, a red dwarf approximately 40 light-years away. Incredibly, 7 Earth-sized planets orbit this star, 3 of which lie within its habitable zone. This compact solar system has captured our collective imagination, offering a tantalizing glimpse into the potential diversity of planetary systems. Closer to home, Proxima Centauri, the closest star to our solar system, also has an exoplanet in its habitable zone. Named Proxima Centauri b, this planet orbits its red dwarf star every 11 days and has temperatures suitable for liquid water to exist on its surface. These discoveries have put red dwarfs at the forefront of our search for life. As we continue to explore these distant worlds, who knows what other secrets we'll uncover? Each new discovery brings us one step closer to understanding our place in the cosmos, and perhaps answering that profound question, are we alone? The quest to find life beyond our solar system is one of the greatest adventures of our time. Red dwarfs, the most common stars in our galaxy, hold the key to this cosmic puzzle. Despite their modest size and cool temperature, they are stellar beacons in our search for life. Their abundance alone suggests a multitude of possibilities. With lifespans in the trillions of years, red dwarfs offer stability, potentially allowing life to evolve over vast periods. The habitable zones around these stars, though tidally locked, could harbor conditions suitable for liquid water, a vital ingredient for life as we know it. However, life in such environments must withstand frequent, powerful flares, a challenge and perhaps a catalyst for life. The detection of planets around red dwarfs is relatively easier, leading to the discovery of exoplanets in habitable zones like those around TRAPPIST-1 and Proxima Centauri. As we continue to explore these stellar beacons, we edge closer to answering the question, are we alone in the universe?